This is 1.5 Part 1 notes. These are on formulas, models, and geometry. So we're going to be basically manipulating some formulas that we use frequently in geometry and physics and all kinds of areas. And we're going to be manipulating them using algebra. So make sure you're taking notes on this. We do have one vocab word right now, and it is formula. Remember, you guys can pause this at any time if you need to. So a formula is an equation that uses letters to represent a relationship between two or more quantities. So places you guys are probably familiar with seeing formulas are in geometry. You might know a formula for the area of a rectangle or the area of a circle, maybe the circumference of a circle, something like that. You're not going to have to memorize any of these formulas right now. There's actually a list of any formula that you guys will need, and they'll actually usually just give it to you in the equation. But any formulas you might need are in the back of your book. If you go to the second to last page, it's kind of like a more construction paper, like heavier page, and there's all the formulas on there. But I will always give you what you need. So we're going to start off with using a formula for the area of the circle. So pause this if you need more time. I'm going to go to the next page. So the formula for the area of a circle is that the area equals pi times the radius squared. Oh, whoops, I totally just messed up. I'm sorry. All right, so erase that. I meant that as an example. So, actually, let's do the area of a rectangle. We're going to start off really simple here. Area of a rectangle. So this one we should already know. Area equals length times width. Now, what you guys are going to get as an example is it's going to give you a formula like area equals length times width, and then it's going to tell you to solve for a different variable. So in this case, we're going to solve for L. That means we want to get the L isolated. We want to get L all by itself. This is just like any other algebraic problem you've done. There's just not as many numbers. There's mostly variables and letters in here. In this case, they're all variables. So we're trying to get this L by itself. I'm going to draw a line through my equal sign, so remember to do everything that I do on one side to the other side of the equation. And what we're going to do here is we don't want this W next to L. It's being multiplied. So to undo that, we need to divide by W. W over W is 1, so those will cancel out. Now we have to make sure we divide by W on the other side of that equation as well. So now we're left with just L on the right side of our equation. And on the other side, don't worry too much about simplifying here. We just have A over W. We can't really do anything with that, and that's okay. You can leave it like that. So for our answer, let's write it more neatly and with the L on the left side. So length is equal to area divided by width. That's our kind of new formula. We solve for L. So this could make it a little easier if you knew the area and the width of a rectangle, like maybe you're painting a room or something. If you knew the area and the width, it'd be easier just to always do area divided by the width to find the length, instead of like trying to plug it in your equation and solve for L every single time. So let's do another example like this. Now we're going to use a trapezoid. So a trapezoid, you might remember, is a four-sided figure. It has two bases that are parallel, so the top and the bottom there are parallel. It has a height, that's the distance between the two bases, and we refer to our bases as B with the subscript of 1 and b with the subscript of 2. Those two subscripts help us just differentiate between the two bases. And yes, you should draw that picture of a trapezoid. So the formula for the area of a trapezoid is as follows. Area equals the height divided by 2 times the sum of the bases. So it's kind of like base times height, sort of, but you have two bases, so you have to kind of find the average of them. So that's the area of a trapezoid. I would give you that formula. Now the instructions here say solve for base with the subscript 1. We call that base sub 1. This one's a little more complicated. We're trying to get this guy by itself. Okay, I'm going to draw a line through my equal sign. Now, just like if there were an x inside of there, we want to get, we kind of can't really get that b1 out until we get rid of those parentheses. So you could distribute the h over 2 to both of these terms, but then we're going to have this fraction all over the place. So instead of doing that, what I'm thinking is, why don't we just get rid of this h over 2 right away? If we multiply by 2 over h, the reciprocal, well, 2 over 2 cancels, and h over h cancels. And that works because the b1 plus b2 is all in parentheses. So it's all being multiplied to that. So if we multiply the whole thing by the reciprocal, we can get rid of it. Now remember, we also need to multiply the other side by that reciprocal 2 over h. So let's write down what we have left. We have on this side just the b1 plus b2, b sub 1 and b sub 2. We don't have to write the parentheses anymore because they're the only thing there. On the other side, we have 2 over h times a. It's kind of like times a over 1. So on the numerator, we have 2 times a, that's 2a. And on the denominator, we have h times 1, so that's just h. So we've gotten a good chunk of the way there. We only have a little bit left to get that b1. Remember, we're trying to get b1. We're solving for that b sub 1. The only thing next to them anymore is that b sub 2, and it's being added. So all we have to do is subtract b sub 2 from each side. B sub 2 minus B sub 2 is 0, so we can cross those out. And we are left with B sub 1 on the right. On the other side, all this stuff, we can't really put anything together. So, and don't worry about that. Just leave it 2a over h minus B sub 2. That's it. I'm just going to rewrite this a little nicer because we like to have what we're solving for on the left side. So B sub 1 equals 2a over h minus B sub 2. We solved for B sub 1. So now, if you needed to know one of the bases of your trapezoid and you knew the area, the height, and the other base, you could just plug them in that equation and solve for the other base that you're trying to find. It'd be a lot easier than having to get that by itself every single time. All right, I have one more example for us. It has to do with interest, and it's accumulated interest. This is called accumulated simple interest. So there's a formula that will tell you how much money you have, say, in the bank or something, if it's gaining interest. Here's the formula. A equals P plus PRT. So the meaning of all of these things, A is your total amount. It's like how much do you have in the bank after however much time you've left it there. That's what A means. P is your principal amount. That's like how much money did you put in the bank right from the beginning. R is your interest rate. So maybe the bank is giving you an interest rate of, these examples will always say like 6% or something. That's a lot. I don't think a bank's going to give you 6% interest. Good luck. But that's the interest rate. And so we'll always have like, 6% would be a 0.06 in there usually. And then T is our time, and we measure that in years. So in this problem, the instructions would be to solve for P. So this is kind of tricky because I'm going to rewrite this equation here. If you see here, we have P in two different terms. We have P right here and in this term, but they're not like terms. We can't combine them. So when that happens, what we need to do is we'd like to kind of pull that P out of those two terms. Okay, so what we're going to do, I'm going to rewrite this part of my equation again, P plus PRT. Think about distributing here. Think about if someone started with a problem and they had distributed a P into these two terms. What we want to do is undo what they did. So we want to pull it back out of each of those terms and put it out here. So this is called factoring, if you remember that. So we're going to have a P on the outside. Now we're going to think about what would have been in the parentheses so that when we distributed, we would have gotten what's up here. So we're kind of working backwards here. So for our first thing right here, well, P times 1 would give us P. And for our second term, P times RT would give us PRT. So if we distributed what's down here, it would give us what's up here. So we're going to rewrite this equation in factored form. So we're going to write this as the total amount equals P times the quantity 1 plus RT. We haven't really changed anything yet. All we did was rewrite that right side so that the P is pulled out of those two terms. So now since we're trying to solve for P, we only have one thing to do here. Here's this P, he wants to be all alone. All we have to do is get rid of this 1 plus RT. It's being multiplied. So we can just divide, we can divide by that whole thing at once because it's in parentheses, it's one quantity right now, so we're allowed to do that. We just have to divide by 1 plus RT on the opposite side too. So that whole group there cancels out, and we're left with P equals area divided by 1 plus RT. I'm going to rewrite that a little nicer with P on the left side. So the principal is equal to the amount divided by 1 plus the rate times the time. So I know these problems can seem a little confusing, but I want you guys to really focus on using the examples we just did as you work on homework problems and other problems. Use those examples and try to see if you can follow some of the same steps. Even if you're confused on one, I want you to try it.